Assalamualaikum. And now I will present the East Coast Rail Line, or called as Ecrl. This project owned by Malaysia Rail Line under the Ministry of Finance and built by China Communication Construction Company. This mega structure has a final approved cost of RM 50.27 million. Its core vision is simple: to connect the east and west coast of Peninsular Malaysia, driving balanced economic growth across the region. Next, the technical feature. This 165 kilometers alignment span 4 states from Kota Baru, Kelantan to Port Klang, Selangor with 20 stations. It includes 219 bridges and 50 kilometers of tunnels. Most notably, the Genting Tunnel will be the region's longest rail tunnel at 16.39 kilometers. Once ready, passenger trains will run at 160 km per hour and cargo trains at 80 km per hour. Finally, the impact. Ecrl will drastically cut travel time from Kota Baru to Kuala Lumpur from 8 hours by car down to just 4 hours. It connects key stakeholders from government body to local ports and community. As of March 2026, the project is 92.6% complete and full operation will be begin in January 2027.
Assalamualaikum everyone, and today we will be discussing the construction technical review part of this project, which is the prefabricated vertical drains, the tunnel boring method, and the new Austrian tunneling method. Firstly, the PVD or prefabricated vertical drains. These are used on soft soil conditions, in which they are used to pour out any excess water in order to stabilize this ground condition and ensure a longer period of time for settlement. These are higher in initial cost but reduces maintenance costs. Secondly are TBM or tunnel boring machines. These are used in long tunnel sections with consistent rock conditions. A TBM is a large mechanized system in which they are constantly installing precast concrete all around the lining of the tunnel. Tunnel boring method provides a higher productivity and improving worker safety than other conventional tunneling methods. Despite the higher upfront costs, tunnel boring methods are often more economical for long tunnels because of their speed and efficiency. Lastly, the new Austrian tunneling method or NATM. These are used for shorter distance tunnel lengths, but they are amazing for unpredictable soil or rock conditions. The basis of the idea is that with each stage of tunneling, they are able to assess the best possible design used for the lining inside the tunnel. This is much more cost efficient and also considered faster than tunnel boring method.
Assalamualaikum warahmatullahi wabarakatuh. So for this part, which is the selection analysis, we will be discussing about three methods involved in Ecrl project. The first method is PVD, second is TBM, and the last one is NATM. So right now we will be starting with PVD, which is prefabricated vertical drains. At Ecrl section 6 Imaran, the site presents a significant challenge, which is the presence of soft clay, which causes above ground stability. This condition made it unsafe to proceed with standard construction activities. To address this, the PVD method was selected as the most suitable ground settlement solution, as it effectively stabilized soft ground before construction stages. The advantages of using PVD are clear. First, it offers cost saving by reducing the needs for more expensive alternative. Second, it improves overall project efficiency by accelerating the construction process. And third, it creates drainage pathway that allows the excess water to escape from the soil. So moving on to the next method, which is the TBM. What is TBM? TBM stands for tunnel boring method. So the challenge here involves constructing the Genting tunnel located between Bentong and Gombak. This stretch presented extremely difficult geological and engineering conditions, making conventional tunneling methods impractical. Given the hard soil and rock condition at the site, the TBM method was identified as the most appropriate choice for this section of the Ecrl project. TBM machines are purpose-built to cut through ground precision. The advantage speaks for themselves. The TBM offers a safer working environment for workers by minimizing direct exposure to unstable ground. It also ensures consistency tunnel diameter throughout the boring process, which is critical for maintaining structural integrity and quality controls. Finally, our third method, which is the NATM, the New Australian Tunnelling Method. For the Ecrl construction phase, the section between Gombak and Serenda presented a uniquely challenging terrain that required a more flexible and adaptive approach compared to TBM. The key factors influence the decision to use an ATM here, which is the need for time efficiency, managing water ingress risk, and the nature of the work involving short distance tunneling in complex ground. An ATM proved to be right fit because it offers greater efficiency in both cost and time compared to TBM for shorter tunnel sections. Its stage construction approach also means the decision can be adapted to suit small and irregular terrains, making it highly suitable for the Gombak to Serenda stretch. That's all for today. Thank you.
So now let's move on to the comparison between the technology used in each of the three type of project. So in first one aspect is the design aspect. All of the project utilize BIM technology to increase the design efficiency. In terms of the system division, we can see that the Shinkansen project requiring more complex system division. This is due to the advancement of the technology used in this Shinkansen project. And the next aspect we will go into is the tunneling aspect. All these three projects uses the tunnel boring machine as the equipment for the tunneling process. This is due to the large railway network that this project consists of. And the final aspect is the railway structure. All of this project uses various type of advanced technology in their project. This is to increase the construction efficiency due to the complexity of work.
Next, let's move on to the challenge and solution. First, the excessive cost. Originally, phase 1 and 2 were priced at RM65.5 billion, which was too expensive for our national debt. To fit this, the government renegotiated with the contractor through value engineering and road optimization. The cost was successfully cut down to RM44 billion, saving us a massive 32.8%. The last one is politics and governance. The project was suspended in 2018 due to political changes and transparency issue. The solution was policy refinement. The project resumed with a cleaner, more transparent cost structure. It now focuses on the bridging the economic gap between the east and west coast while aligning with the sustainable development goals.
We also, in this project, we did some prediction regarding the future challenge that might occur if the Ecrl project will be continued into the next phase. So now let's move on to each of the situation. For the first situation, we can divide the situation into two problems, which is the first one, located near the water source, and the second one is existing underground structure. For the first problem, near the water source, we can overcome this challenge by using secondary pathway. This solution has been applicable in other projects such as the Shinkansen Maglev project. And for the second problem is the existing underground structure. We can overcome this challenge by application of the BIM. This solution has been applicable in the MRT line project in Malaysia. For the third situation in this situation, we can the challenge is the underwater drainage system. This is the prediction if the Malaysia want to connect the west and east side of Malaysia. To overcome this challenge, we need to apply the suitable technologies and careful planning. This solution has been applied in the Shinkansen Maglev project, so it is not impossible.
Assalamualaikum. As for now, I will present to you the sustainability in the Ecrl project. The East Coast Rail Link is one of Malaysia's largest infrastructure projects with an estimated value of 50.27 billion ringgit. As the railway route passes through hilly terrain and tropical rainforests, sustainability is an important consideration throughout the project. Various initiatives have been proposed to ensure that development is carried out responsibly while minimizing negative impacts on the environment and society. From an environmental perspective, the Ecrl promotes greener transportation through the use of electric powertrains. Compared to road transport, rail system produce lower carbon emission and help reduce traffic congestion, contributing to Malaysia's sustainable development goals. The project also focuses on protecting wildlife and natural ecosystems. Measures such as eco bridges, wildlife tunnels, and environmental impact assessment help reduce disturbance to animal habitats and minimize environmental damages. In addition, sustainable construction practices, including proper waste management and energy efficient machinery, can further reduce environmental impacts during construction. From a social perspective, the Ecrl improve connectivity, especially for rural and underdeveloped communities. Better transportation access allows people to travel more easily to school, healthcare facilities, and workplace. Community engagement is also important, as authorities and contractors should work closely with local residents to address concerns related to land acquisition, noise pollution, and safety. Furthermore, stations and facilities should be designed to be accessible for the elderly and people with disabilities, creating a more inclusive public transportation system. Economically, the Ecrl supports long-term growth by improving connectivity between regions. The railway can reduce travel time and transport costs for both passengers and goods, which helps stimulate trade, tourism, and investment. The project also creates job opportunities during both construction and operation phases. Through skill and technology transfer, local workers can gain valuable expertise that supports the future development of Malaysia's workforce. In conclusion, the Ecrl demonstrates how major infrastructure projects can contribute to environmental protection, social development, and economic growth while supporting the principle of sustainable development. That's all from me. Thank you so much.